Let me a second. Yeah, you can start when you are ready.
No problem. Thank you. So, yeah, I think my point is today we'll just quickly walk through some potential platform to develop a quantum game in case you're looking to work on some hackathon projects. Maybe you can start with some quantum games. And as I wrote in the introductions or like abstract in my talk, I think game development is actually very close to simulations. So in my when I'm doing some chip design, or maybe you're working with some small projects or some engineering project, we usually encounter the simulations that basically we encoded our physical law in and ask computer to do some so basically we give them the model, and then they based on physics law then tell like maybe there's some stress, some position and stuff like that. And it's pretty much the same in game development. So if we actually, I think we can just start with a quick example. So for example, this is a online coding link that I'm going to put in the chat. I think we have a chat, right? Yeah, we have a chat here. Everyone. So this is, I'm not affiliated with Pico 8 or Leftfield Games in any sense, but this is a quick interface that you can just put in some code and then start to run and just to, and they also have some place. Oops, sorry about that. So potentially we can just draw up something that's, quickly, then you can just run the code and see how things evolve from there. We'll give you this, for example, I put in some code and then you start to see something is running. And it's actually very simple, which is basically in each frame, we'll walk through this later on soon, but just quickly walk you to give you a sense that why I meant, what do I mean by game is actually very similar to simulation, because there are actually some physics law. Oh, by the way, I have a big screen here, so I'll be most of the time I'll be looking in this direction. Apology for that first. So the idea is you have some physics law building that's in this case is just a constant velocity moving in some direction, and you have boundary condition when the position of the location of the target is moving to, when it's bigger than 120 or less than 0, then you'll do something. Basically, you just do a collision and then reflection, basically reflection. It's the movement will move in from left to the right or from down to the up. So you see some sort of like collision feature that is just running to the edge and then bumping back and forth. So this is what I mean by when you're doing a game, actually you need to put in some physical law. So that's when the player play your game, they'll feel, okay, this is something that they can manage. But in the meanwhile, we can also tweak the game, like tweak the numbers or put in some new physical law. So in our case, or in the case in the field that I'm interested in, is actually we put in some like physics law that involves quantum information science or even quantum physics. You can do some, you can play something, and then you can also liberate, like changing the law a little bit and see how things evolve from there. And that is actually the part that's where I see that there are a lot of similarities between games and simulations in this sense. So if you so I guess we can after like putting those words in front, we can start with the talk. So the first slide I try to show you is if you look back into the history of hardware development, we're actually seeing a short period of time that right after the very first or like very young hardware in the silicon technology, like that means that when after around 1971, we see the 4-bit chip from Intel, which is this number there, the IC4004. And if you look into the technology, it's actually not even a CMOS process. It's just a MOS device, and with LSI technology, it's not even VLSI, it's just LSI technology and MOS architecture. And what is more interesting is it only have 4-bit, right? So at 1971, we have a 4-bit IC, and but around like 4 years later, they have the 6502 chip for 8-bit game consoles. So what I want to convey in this slide, what the idea I want to convey in this slide is actually, even if when the hardware is still limited, so you can see that even just have an 8-bit chip, there are already people wanted to use it to put into the game console. The reason is because game console actually require the requirement is not that stringent. If you want to play a game, you don't really need to go into very, like, of course you can go into very heavy lifting calculations like the 3D games, but in the meanwhile you can also actually you can also create some small games, and then just to practice how you code, how you do the coding, and how do you play with the information encoding and interact, experiment on the input output and interact with the player. So it's actually a very flexible field that you can start with, even though maybe the hardware is limited, maybe our knowledge is still limited in terms of coding. So I would say playing the games and creating games together with this idea of simulations is actually a very good test ground, or like experimental. You can do some experimental with to begin with when you are learning some new field, even you're just a classical coder, or you by then like you are a software engineer that's more familiar with classical computer, or you're more like me, like a physicist, quantum physicist, but you are not very familiar with coding. So creating games and playing games are actually a good starting point, even though we have very limited quantum hardware at this point. Right. And today's agenda is basically, I think you already heard how I started this my quantum journey, right? So I think I personally like play games, and I think playing games and also creating games are a good way to practice my knowledge, and also on the limited hardware platform. Right? And then so what's in the following hour, or maybe a few 20-30 minutes, what I'm going to discuss is maybe there's some, I have some personal tips to do some quantum game developments that you can. The first part is actually we can get some inspiration from existing quantum games, like playing the quantum games that other people did. And another important part is actually I want to quickly show you some current implementations, and maybe a little bit pros and cons. And then the most important part is actually we dive into some quick hands-on practice. Now, basically what we'll do is copy paste the code and then in the chat, and then you can just play it around when you find time is convenient. Right? So to begin with, there are actually, I think I probably will send this slide around to either Sam or Elizabeth. So if you are interested in looking into further, you can just click the links here. You can just click and then play a little bit on it, and then think maybe you can in what sense you can kind of improve it, or just make it better, or make it fun in a different sense. Okay? So I try to put together, I try to, categorize them into 4 categories, but these are just definitely just personal, my personal attempt to do this. And so while so far the games I've seen in quantum games are fall into 4 categories, 4 different types. The first types are actually, they are trying to simulate some quantum phenomena, or like phenomena in quantum physics. For example, you can have a in this game, you basically you put in on the they literally just you're doing the experiment like photonic experiment. You have the deflections, and you have mirrors, and then you have those photonic parts that you can work with the photons, and when the photons go in, like get reflected or deflected to the apparatus, like photonic apparatus, you can see some interference or some kinds of like construction or destruction interference. Right? So basically, this just also there's other different kinds of game. Maybe you change the potential and see how the wave function evolves in that case. So these are all like simulating the real quantum phenomena. So there's one type of game I'm seeing, and the second type is actually I call it quantum inspired rules. It's basically you like collect like maybe just read on the book like quantum information science about some chapter that you have this GHZ game, and you have some like in the circuit you see some interesting properties, and just put it into more like you just like basically you wrap it around with some gambling theme, like you play some game or you flip the coin or you do some kind of way that you encode the quantum information science into your game rule. For example, we are flipping the game, right? We are flipping the coin. As when we're playing a game, we flip a coin, and zero is head and one is tail. But if we put in the Hadamard gate, how does it look like in that case? Like maybe it's flip. But of course, you need to define the game such that the player are, or like the people who are interacting with the game will know what is going on. So you can have a better gaming experience. Right? There are a lot of things, and also you can encode those like the rules into the maybe like chess, like you're playing a chess or like tic-tac-toe and stuff like that, right? And also, or maybe you can play around with some phase, and then you put in the ideal phase, like maybe you rotate from 0, rotate to 1, you have 180 degree, right? And in the game of the typical battleship game, that you need to hit the battleship for 3 times, for example, and you can basically divide it the 180 by 3, you get like 60 degree each, and then if the target was hit by 3 times, then you can defeat the battleship, for example. So basically, these are all quantum inspired rules that you can try to encode the game into your game rule, and then people can start following on that. And then there are also puzzle solving. It's always the most simplest one in terms of the game development, because when I say simplest, I mean that's basically the mechanism is easy to understand, because you have puzzle, you want to solve it. Maybe you want the player to interact with the game through basically just a piece of puzzle that you need to place a gate this here and there, and then you want the player to match a certain kind of outcome, right? So there are all this kind of is also a popular theme that I've seen so far in terms of quantum games. And of course, there are real-time interactions, and this is actually the example we're going to talk about today, because I think this is actually some part that's as I personally see is one interesting interaction to start with, when we are working with some primitive quantum computers that potentially we can work with. So, so this is the coupon that's I think many of us know, but if you haven't, you can feel free to try it. I think I can start the sharing. I think potentially I can just put the link down there. Oh yeah, thank you, Sam. So this is so Sam just helped me to put in the link into the chat. The coupon is basically developed by one of our great qiskit advocate fellow, Junye Huang. Huang Junye, he actually put in this game back in, it's already 3 years ago. And the idea of this game is basically it's just like the classical games, like classical pawn games, the iconic one by Atari. It's also like 20, 30 years ago already. And the idea is basically you move the pedal to hit the ball, right? So on the right is a player, and on the left is a computer or AI. And you can actually, so the idea is the location of the pedal has been encoded into 8 different locations and encoded into the binary representations of 3 bits. So if you, for example, if you in this sample is XX, and then there's nothing here. If XX there, you see it should the move to 110. So if XX and nothing here, and this result, the end result of this circuit will give you the idea will move the pedal into 110. And in the meanwhile, there are actually Hadamard gates you can implement, you can put in this game, and they actually make your pedal show up at 2 places simultaneously. Basically, this idea of this superposition, right? So, but in the meanwhile, when the ball comes, the game was designed such that you will do one measurement, one shot measurement, and what will end up with the state, the quantum state was we call it collapse into a single position, and then the pedal will just move there. So, for example, if you have there's no example here, but if you put a Hadamard gate here and there's no gate here, then you were expecting the state to be 0, 0, 0 and 1, 0, 0. And when the ball comes, the game was designed such that you will do one exact measurement, one shot measurement, and it will either collapse at 0, 0, 0 or 1, 0, 0. So that's how the pedal will end up with. But it's actually not controllable. It's just it's actually probabilistic, right? So, oh, sorry, I actually can read. So if there are questions, Elizabeth, can you help me to just interrupt me and then let me know what the question is?
In this moment, there are no questions about the presentation.
Oh, okay, that's great. So the part that I really like this game is actually it's really fun, and because of the time constraint, like the ball will fly from this on left to right in a given amount of time, and you really need to like be very familiar with how this gate works, and then what are the this gate represents. I mean, if you flip it and you become 1, right? And if you're a Hadamard gate, then it can actually potentially help you to align the place better, because you can actually see that you can tell that when a ball comes here, it's hard to read where exactly it's gonna locate. So it's actually a little bit challenging at the beginning. But with Hadamard gate, hopefully that can make things easier, because literally you can potentially have a longer pedal here. But it's a little probabilistic, so that's something that we need to like use it wisely. But the idea is basically it give us a chance that to train the user to provide to solve this problem in real time, and this real-time interaction remind me of a game that back in 1980s when I play on when it first appeared in Microsoft. They're actually, but that's in like Mandarin Chinese. So in Mandarin Chinese, we need to like type, I think, but these are kind of pretty common. So basically, this is like train at that point, like people want to train like the general public how to use keyboard, right? And then you can, so that kind of game is kind of you input some, you just like type in, it's a typing game. You just type in on the keyboard and to match some letters. This is basically what happened in those games, that you have falling letters and you need to you need to type and then you match the letters. So and so this kind of, I personally view this kind of game is similar to that. Basically, you want to train the user to be familiar with sort of kind of input. In this case, it's a quantum circuit. And you need to, basically what you're seeing is you need to map the pedal, in this case, to a particular state by using the quantum circuits. So if you are looking at in the game I mentioned before, it's like you are using a keyboard and you should match the letters. And here you are using the quantum circuit to match the quantum state. So from that, what programming language do you usually do? Okay, in my case, it's Pickle 8, and I think it's because of time. I think in the interest of time, I'll probably just skip this part. And I'll come back to this later. How do I create a new game from Coupon? But since we already have the questions, and so so currently there are 5 potential platforms to do the to work on quantum games. That's the part that I'm familiar with. There are definitely more, but just I'm not very familiar with the rest of them. But here I'm just providing 5 ideas that you can look into, and they're all links here. So the first environment is just using Python, that you basically install the Qiskit and the Pygame module. Then you can start from there. If you're familiar with Pygame, this is great. But personally, I think that I have the problem I have with Pygame is actually it's very difficult to distribute. Once you pack it or like you wrap it, you become more than 100 megabytes. It's not very easy to distribute. Like what I meant is basically not much people want to download a simple game like with a size more than a few hundred megabytes. And also it's not very easy to design your graphic and sound effect. So it's actually not very convenient. And the main reason behind this is basically the Pygame need to wrap all the feature in Qiskit. That includes the matplotlib. That is the most that part takes a lot of space, and usually you don't really use that in. No one brought the scientific graph in the game. I mean, not much. But the idea, but what is good part is that it has full Qiskit support. So if you look into some like pulse module, Qiskit pulse module, potentially you can explore those possibilities using this approach. And also if you only know Python like me, and this is also a great starting point. But in terms of real gaming experience, it's not personally. I don't think it's very ideal. There are of course a lot of good games made by Pygame, quantum games by Pygames. But anyway, there's another way of doing this. If you are more like a software engineer, there are potentially some simulators in JavaScript. So basically, what you want to do is you need a quantum simulator kernel. So basically, it does those quantum simulation part. And there is an example that I found online that has a JavaScript. But personally, I'm not a JS user, so I don't really know that. But I know a lot of people. So I work with many people that develop quantum game during this past 2 years. I've joined Game Jam and also some hackathons. And there are a lot of software engineers that are really good at JavaScript. So this potentially can be helpful. But again, you will need some simulators in these cases. And the issue is there are not very many public simulators. And as a result, you have a little bit limited support resources if you want to learn start from here. All right. The next one is the main part. I found that is more feasible, and it's actually increasing. Yes, increasing the support is the micro-qiskit code developed by Quantum Jim. It's also he's also a research staff member in IBM here. So the idea is the whole team they actually create a bunch of native quantum simulation code. Basically, what happened here is like, for example, in C# they just use the syntax of C# and then create this kernel, the whole simulator kernel with this corresponding platform. Like if you're working with Unity, then you can go into here and look into the possibilities. I should just post this. So So this is the micro-qiskit. So you can find your favorite code, and oh, they have a JavaScript as well. Well, actually, I didn't really look into that part. So so basically, what happened here? They use the native code. Like if you are looking to this C++, then basically using the C++ syntax to write a quantum simulation kernel. So, and in the example today, we're going to use Pico 8 that fall into this Lua language category, and we'll look into that soon. So in that case, what we're doing here is using Pico 8. As an example, you're working on the Pico 8 game development platform, and it's using a Lua language. The issue of Pico 8 is it's actually not open source, and it's not free. It's $15 for lifetime authorization. But in the meanwhile, these years, they also actually Pico 8 actually provide an education link that you can basically just code it online. You don't need to buy it. It's totally free. But the limitation of this part is you can actually export the game. When you finish, you need to actually you want to play it. It's like distributed. It's a little bit limited here. But it's like $15 for lifetime authorization, so licensing. So yeah. All right, and the other part is the next one is actually the Qiskit and Python flags. Then with the Python flags, you can actually the Python module called flags. You can actually connect interface with Unity or Gaga, like those professional game development engine. The process, of course, is easy distribution. Like you have a standard way of distributing this. Basically, you have web interface, and you have also a huge number of developers that can be helpful if you if you get into troubles, go into bottlenecks. Okay? But the issue, at least for me as a physicist, the issue is not very friendly for us. But you're a software engineer and you know how to work with flags. I think this is actually a better approach. Might be a better approach for you, because you can actually leverage those design like resources, like game development resources from the big number of community developers. And the last but not least is actually Qiskit in Unity. It's actually rather new. I think it's developed like in this also I think it's already a year or so, more than a year already. And it started and the good part of this one is actually it can directly interface. It basically bypass the flags issue, and you can just like directly interface the Qiskit. It's actually written the Qiskit code in Unity environment. So, which is also very good. But I haven't really looked into it too much. I tried to play a game there, I mean, create a game there, but I don't think I'm that good in Unity. So it's a little bit unknown territory for me at this point. So I see a question from Isaac.
Yes, there is a question in the chat.
It will be similar to actual video games. Another question, do you think GAN could help with? Oh, okay, that's great. So there are two, there are basically Isaac had two questions. The first question is, be similar to the actual video game. The reason why I'm bringing up Unity in this last two categories is because this is the part that it is going to look, we hope it to look like the actual video game. So we are leveraging the classical, like how the classical software developers, how they do in game development, right? They usually just design a game in Unity and Gaga. So what we all, as a quantum scientist, what we need to do is basically provide a way to basically what we call it, the terminology is called provide a simulation backend, or like quantum simulation backend. So basically we have some part that has to be done in quantum, and so basically we wrote the code. Like if you need a C# in the spirit of micro-qiskit, it's like if you need C#, we just wrote the simulation code in C#. And when you need to, so basically you are creating maybe maybe you're creating some, I don't know, maybe room escaping, and then you need to the user need to solve a puzzle, like room escaping game, and user need to solve a puzzle, and that puzzle need to match to you need some answer to the puzzle, right? And then how the computer can tell is through these simulations that provide some answer to this, so the user can, the player can interact with it. So a short answer to your question is, it will look at like actual video games, and so it is happening now. Like that's why we play games, like what we do games here, and we want to make it as appealing as possible. So that's why we're leveraging those professional development tools that we usually do. Okay? And the second question is that this is also a very interesting part, that the quantum games, if quantum games, so if the quantum games can actually provide some helpful part in the and I will invite you to look into this part. It's called a quantum blur. So quantum blur is actually, this is actually a little bit in between they call it quantum inspired art and quantum games. It's basically you are creating some kind of feature based on quantum information science, like either entanglement or of course the superposition, right? But in this case, the quantum blur is actually a generated, like they call it procedural generations, procedural generation that basically use computer to generate some features, or like maybe it's artistics, or maybe it's more like calculation efficient. Like it requires less amount of calculations. But these are so far still very experimental part, and we also need to work with artists to see how things are blended in and visually appealable or something like that, right? But there are definitely a lot of quantum, like visual processing work is happening now, that see if there is some way to accelerate the process, or if some unique way that a quantum can help in terms of this approach. So these are great questions. So what could the bottlenecks of the game developments, for example, rounding algorithm, the number of qiskit? Yes, so it's a great question from Mingguo. So the bottlenecks of the game development is, first of all, I think most of the issues I've seen so far is the scientific correctness. Sometimes it's just not very easy to implement it to be scientifically correct, but that's something that as a developer we could improve. The running algorithm in qiskit, it depends on how large your problem you're going to use. In my case, for example, in QPON, if you are just encoding 8 locations, that will need 2 to the 8, right? Okay. 2 to the 8 actually. So you need 3 qubits and you can encode to 8 positions. But you can imagine that if you are moving to like 5 qubit, you have 32 positions. But in that case, even a human, I have hard time to align moving one to the other, and then try to align those 32 locations. So I think that I do not see major issues at this point if you are just creating some simple games. But if you are going to match something that's very like a large number, that eventually you need that, then there will be some bottlenecks. But from what I can tell now, even the Pico 8, it can support 15 qubits, and a typical laptop can support 30 qubits. But as you can tell, 30 qubits 2 to the 3 times. So that's a huge number of state, right? If you are trying to encode something. So, but yeah, another issue is basically the other limits I don't know is how fast it could be. So like for example, in those like fast real-time response game, you actually do not want some like huge latency, because these are running at 30 frames per second. So if you're some latency, the user will feel that, and the game just becomes sucks at that point. So that's another bottleneck that I actually never tried it. I don't know starting from which part the maybe 10 qubits or maybe 12 qubits. I think as 14 qubits is definitely not unplayable if you are doing this in some other using your game. I think 14 qubits will become unplayable in the Pico 8 environment. It's just the coding, the efficiency of simulation simulator is not good enough. But that also brings to another question that if we can use a real quantum computer, that will, in that case, we'll need to find a better way to interface. So right now we're actually using a quantum simulator kernel. If you want to interface with a real quantum processor, then we also need to solve the latency issue. And that part is something that I think not many people are working at that point yet. So VR and AR, I think that's a part that we want to experiment. That definitely is a good way to experiment, but that'll go back to another question is if quantum is really providing some improvement. If not, I don't think quantum can beat those AAA works, right? Like those big game works, because these games are more, I think quantum game developers are still in the regime or more like indie game developers. Like you have some ideas you want to experiment with. And that's actually why I encourage people this thinking, like trying to look into those, like starting with some, when you're trying to pick up a platform, I would encourage you to find the one that you're most familiar with, and you can start with with a lower threshold. So instead of looking into something that's more like professional, you actually, I would suggest is you find the one that you feel more comfortable with, because you're probably not being able to demonstrate some like accelerations or like improvement dramatically, but at least at this stage, with those limited hardware, what we can do at this point is to experiment some ideas and creating some indie games, becoming an indie game developer in this sense. So another question Elisa has is incorporate AI in quantum games. That is, I think that goes back to the same question as AR and VR. They are all possibilities but more importantly, I think currently we're looking into a game that is more like indie game developer. So you have some idea, you want to experiment with it, you can go and do it. But if I'm going to combine something else, it's probably not that easy at this point to do that, because first of all, we do not have, I'm not sure we have that good compatibility to those professional engines. Like I would imagine in AR VR games, you probably need some kind of different development engines, like game development environment that is not necessarily have their quantum simulator. You need a simulator code there, and I'm not sure about that. And but there are a lot of works in terms of incorporating AI in quantum development, like quantum algorithm. For example, you have a quantum machine learning, but that's a different way of incorporating things. But so far, I'm not sure I've seen those AI into quantum games. So real quantum computers are error prone. We're not able to support QPON. Oh yeah, David has a valid point. Yeah, there are also like in the real computer, we also need to take real quantum computers need to take into account errors. But this is something that could be experimented. Like I say, quantum game is something that you can actually, I mean, their software developer always say that it depends. It could be bugs, but it also could be features. Right? So potentially you can create a game that make it so unpredictable, or maybe somehow people find a way, a user find a way to make it predictable, like how you include those code into your game, and then can potentially create some problem solving again in that case. But again, that would in order to have, I think the most important part is we need a good user experience so that people will hook up to your game and they want to play. And then in that case, you'll get feedback from them and you can improve your game. So on that basis, starting from that basis, like this kind of assumption, these tools are the most important part, that you need to know what are the limitations of, and you really need to get into it and experiment it. And what are limitations, what are latencies, and stuff like that. So for 3 qubits, potentially there are still some kind of, there's still some interesting part that you can look into, even just coding, like encoding 8 pieces of information into 000 to 111, right? So I think we have a little bit more time. I can go a little bit over time today. I mean, like 2, 3 tests. So we have like 15 minutes left. So what I'm trying to do here is, so if you haven't done so, feel free to go to this link. Again, I'm not affiliated with this game in any sense. It's like this development, like Pico 8 in any sense. It's just I found this is the easiest way to introduce quantum game development to general public. And if you go into this game, you just click those. Let me just restart. So you just click this one, and you just hear a sound, and then press ESC, and you're going into this interface. And what I'm asking you to do is to copy paste this part of code, and then you press ESC again, and then type in the terminal run, and you'll see something is the ball or like the feature is moving and it's following this collision. And if you root and you press ESC twice, and what you see is you actually go back into the coding, and you can try to experiment everything you want. Like you can change the number dx dy just to understand how things works. But if you look into this, you'll see that it's moving faster. Right? You can move 30. So that's what I meant is that is the part of what I meant is why it's quantum game development, not just quantum game. There's no quantum at this point yet. It's why game is looking just like simulations, because this is what we do when I'm simulating it. For example, I'm simulating a quantum processor. Like we have a circuit and we just tune this, tune that, tune some numbers and see how the computer it follows some physical laws, and you just see that how things works. Like you change this and change that. Right? So this is a quick example showing you how the games can be done in this way. So at the beginning, you have initialization. It tells the computer what is X, what is Y, and then later on in these two sections, it will actually refresh the it will actually loop these two. The code will loop through these two functions. These are the unique functions that's used in Pico 8. So underline init, it will run this function only once, and underline update, it will run, and also underline draw, it will run these two part sequentially, and in every 1/30 seconds. Basically, it supports 30 FPS. So it would run 30 seconds, 30 frames per second, and just to update those features. So what happens here is if you are starting at 64, and in each frame it will increase like in 2 or like 2 or 30. It will increase in the X direction, it will move 30 pixels. And in the Y direction, it will drop 2 pixels. The 0.00 is here, and 128 is here. Right? And you will have some boundary conditions here. So that gives you the idea. And the end, at each frame, actually, I refresh it. I clear the screen, and then ask the computer to plot the sprite. This is what we call sprite. This small pieces here that it's a sprite, and it corresponding to sprite sheet 0, and plot it at the X and Y location according to this one for each frame. Right? And here you have the sprite sheet. You can draw up different sprites. You can do this and do that. And you can change that here. You can run it again. You see, so the whole thing is messed up here. Let's do this. So you can see that I just changed the sprite. And actually, I put in the sound effect here. So if you are doing this, you can actually go into here. You can press space you can just use the mouse to drag and then press space to hear how it sounds like. So when it goes above 120, then you play the sound. It will not just you'll go back, but also play the sound. So you hear this sound, right? And you can potentially do that to whatever you want. Maybe second one. Faster. Okay, let's run again. Okay, so it's -1. So it's when X, so it's on the right, you will play sound F1s, and on the left, you will play sound effect, sorry, 0 and 1. So 0 and 1. So this is just a quick way to give you an idea how things look like and how do you write a game. And it's actually a classical one because it just have collisions. Okay. So the next one is actually, the next code I have here for you to try out is the micro-qiskit one. Let's see. Okay, so there's a little bit more code here. Copy paste this in. And these are code that I found is useful for me, and potentially you can just keep it. You try to use Pico 8. Oh, it's very too much. Okay, I think there are some limits, like number of character limits. I think I will send you. I will like attach the. I'll just send the Elizabeth the code later on. So when you can try to follow up. But anyways, once you get the code, you can just basically copy paste this code and then try to run it. Okay. So what happened in this code is I include the micro-qiskit part. So this is how you use micro-qiskit code. You go to, you basically just copy paste, and that's a good part of. It's a good part of writing everything in its native language. So basically, you just go to LUA, and you have micro-qiskit.lua. So just basically copy paste the entire part into your development environment. In this case, is Pico 8. And what you do is you use them as a function. You use those parts as function. Like you have math and you have quantum circuits. And in terms of this, you basically just use it. If you know Qiskit, then you'll be familiar with this, how you wrote this. You basically have your qc.x.y.z.h or rx, for example. So basically the whole idea is similar. Let me figure out the code. So in this example, you can actually, I set a flag here. You can put the Qiskit demo to true. And I wrote the small functions that basically convert. I don't really like how this the Qiskit code export. It's not very convenient for me for my personal habits. Personally, I feel this way is better. So what I do is I put a small wrap up. I wrap it up a little bit. So you put in the quantum simulation, and then you basically you have some you export. Basically, there are explanation here, so I won't spend too much time. But what actually happened is you provide a state count, the state description, and so the count. So you have 0, 0, and how much, like 0, 0, 1, and how many you get in 0, 0, 1 in each shot. Maybe you get 16 shot, and you did the measurement. You have a shot of 0, 0, 0, and a shot of 0, 0, 1, for example. So you'll return accordingly those numbers. And so what I'm going to do here is I'm going to show you a piece of code that's, I'm just trying to explain why it looks like literally like Qiskit. So I define a number of qubit to be 3, and I set the count, the measurement count, to be 2 times 2 to the 3. So basically 16. So if I have 3 qubits, you will do 16 measurement, and you can define the QC equal to quantum circuit, and QC, and then you set the register to classical quantum bit number of quantum bits and number of classical bits, and just run. I basically here just run a for loop, just attach to, actually here I just attach to the 0 qubit. Only the 0 qubit has QC. So I basically have QC.h at 0 qubit, and then I put a CX from 0 to control node at 0 to 1 and control node to 1 to 2. So basically, if you're familiar with the Qiskit, this is like quantum information science. This is basically a GHZ circuit, and it will give you a 0, 0, 0 and 1, 1, 1 state, and I run the quantum measurement, and it will return the QC and count. So if you look at the what I run earlier is it returns 0, 0, 0 and 1, 1, 1 and count 8, 8 because I have 16 shot and then I have 8 shot in 0, 0, 0 and 8 shot in 1, 1, 1. So the next part is will be where you want to use this code. I'm just demonstrating how do you run the quantum circuit. And the next part is how you encode it. Then that will be everybody's homework, I guess. Just if you want to run the quantum games, you already have those code like encoded. You can. The next question, how do you encode the game? And I think I have a little bit more time to talk about this. Sorry, it's 3. I told Sam that I only have 1 hour, but it turns out I probably need more. But the next.
Don't worry, we start later.
Okay. So the idea is the next part, I'll just quickly walk through how I play the game, how I develop a game. So now we know how to run the quantum circuit. Oh yeah, just in case, we can actually run something that's just to convince you that it's really this thing. So I will just from I to 0, 2, and 1. I think in this case it will give you QCH. So in this code, it will create a quantum circuit at QC.H0, QC.H1, and QC.H2. So basically, that create a fully so in the previous so in this case, fully superpositioned circuit. That means we should expect 8 outcome 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and stuff up to 1, 1, 1. Let's take a look. So run. So 0, 0, 0, 0, 0, 1, blah, 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 1, 2, 3, 4, 5, 6, 7. Okay, so now you see the power of this count, because I do not have enough count here. So potentially there will be some state, like for example, I have some state that I pick up 4 times, that do 1, 0, 1. So in that case, I have a missing state here. But if you do this, maybe I just times 4, I increase the count by 4 times, then potentially you'll see 8 state, 1, 2, 3, 4, 5, 6, 7, 8, right? And you have all possible states shown up here. And this is actually some features that I'm going to tell you in the next, when I try to run my game, when I try to do my game. So in my game that I attempted to do, 5 minutes probably. So we talk about this the coupon, right? And from coupon that you can actually, if you look into the mechanism of this game, it's actually pretty simple. You have 8 locations, but the reason, but in the meanwhile, you have only 1 ball, right? And it is because of this fact, it only has 1 ball, that it's actually not encouraging the user or the player to use Hadamard gate, because if you use Hadamard gate, like I mentioned before, you ended up with, you need to take a measurement in order to make sure that the pedal is falling at some position. And at that point, when you do the measurement, it's a random thing. And so they will kind of like scare off the player like a user from using it. So it's not accurate. So the one thing that I was thinking maybe I can try to do is creating a game that encourage people to